Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Dear student, Assalamu alaikum. Today we are going to start uh, class 9th subject physics, chapter number 7, properties of matter. We are doing. Topic of today's lecture is 7.7, 7.8, and 7.9. We will try to finish this, but I'm not sure we will be able to finish, but we will try to finish. Okay. Pages covered 158, 159, and 160, and I will tell you the more pages if we go on. So please open page number 158. The topic, this is the chapter we are doing, properties of matter, unit number 7. Today our topic is 7.7 and the name of the topic is principle of flotation. I repeat, principle of flotation, which is on page number 158. Please open page 158 and the topic we are going to start is principle of flotation, which is 7.7 topic. I read, an object sink if its weight is greater than its upthrust force acting on it. In my last lecture, we discussed about the upthrust force and we calculate the formula rho Vg to calculate the upthrust force. But in this topic, we will study why the objects sink and float on the water. The reason, what is the reason behind the object floats and what is the reason behind the object sinks. Okay, the object will sink, it's mean it will dip into the water if its weight is greater than the upthrust force. You know, I told you in my earlier lecture what is upthrust force. Upthrust force is the reaction. Whenever the body is on the surface of water, the upthrust force is provided by the water. The water is acting on that object which is floating or sinking in the on the surface of water. So whenever the body is on the surface of water, the upthrust force acts on the body. So that is provided by the water. So if the body will sink if uh, if the weight of the body is greater than the upthrust force, and similarly the body will float if the the if the if when an object floats in a fluid, the upthrust acting on it is equal to the weight of the object. If it is if the body will float if the upthrust force is equal to or greater than the weight of the object. So this is the principle of flotation. The body will sink if its weight is greater than the upthrust force, but the body will float if its weight is equal to or if the upthrust force is greater than its weight. The body will float. We will study the example for this more clearly when we go up. A floating object displaces a fluid having weights equal to the weight of the object. Archimedes principle is applicable. We studied in our last lecture Archimedes principle, and Archimedes principle holds for both liquids and gases. If it is liquid, it is hold. If it is gases, it will hold. We find numerous applications of the principle in our principle of flotation in our daily life. I explain you the example right now. After explaining example, we will do this numerical. Okay. Next, examples are ships and submarines. Ships and submarines. You might have seen a wooden block floats on water. There is if a piece of wood, if you dip on the water, it will start floating. It will not sink. It will float. The reason behind is the weight. Its weight is less than upthrust force acting on the object. Upthrust force acting on the wooden block. So I told you the body will float if its weight is less than the upthrust force, or equals to, or the upthrust force is greater than the its weight. So then the body will float. It is because the weight of the equal volume water is greater than the weight of the block. As I told you, upthrust force is greater than the weight of the block. That's why the wooden block is floating. According to the principle of flotation, a body floats if it displaces water equal to the weight of the body when it is partially or completely immersed in water. As I have told you, from here to here, this is the reason behind why the object floats on water. Now we discuss about ships and boats are designed on the same principle of flotation. When the ships and boats are designed, because ships and boats carry the passengers and goods, that's why they are designed on the principle of flotation. They are designed by keeping in view that they carry the passengers and goods. That's why they are designed on the principle of flotation. If the the ships and boats floats a heavy ship, there are the bigger ships. They are carrying the goods and the passengers. They are floating on the surface of water, although they have a bigger weight. The reason behind is they are designed in such a shape that their upthrust force of water is greater than or equals to the weight of the ships and boats. So if I told you the object will float if the upthrust force is greater than or equals to the weight of the object. So since the weight of the object we design, the designer designed the ships on the principle of flotation. They keep in mind their weight must be equal to the upthrust force by the water. Similarly, we have a submarine can travel over as well as underwater. We have a submarine. This is a picture of the submarine. It has it has it has tanks uh, inside uh, inside the submarine. They have the tanks. So when they want to go into it can float and it can sink at the both time. It has two functions. It can float over the water and it can sink under the water. The reason behind, if it wants to go under the water, the tanks in the submarines are filled with water. So by filling the tanks, the weight of the submarine is greater than the upthrust force. Then the submarine goes under the water. This is the reason the tanks are filled when it wants to go under the water. The tanks in the submarine are filled with water. So by filling the tanks, it means we are increasing the weight of the submarines. So I told you the principle of flotation is this. If the weight of the object is greater than the upthrust force, the body will sink. So the reason behind, if it is want to sink, so the tanks in the submarines are filled with water, and so increasing the weight of the submarines, and it goes down. But when it wants to float over the water, so it has two functions: it can float and it can sink. So whenever it wants to float, the tanks in the submarines were emptied. They were emptied. So at that stage, emptying the tanks means the weight of the object is equal to the upthrust force. So in this reason, it can float and sink at the same time. So this is all written over here, why the submarines float, or when the submarine floats and when the submarine sinks. Okay. Now we discussed about the examples. As I told you, I will explain you the example 7.5. An empty meteorological balloon weighs 80 Newton. It is filled with 10 cubic. It is on page number 158. We are discussing the example 7.5 by using the Archimedes principle. As I have told you, we will use Archimedes principle, which is in our last lecture we derived this rho GV. This is called Archimedes principle. This example 7.5 is based on Archimedes principle, which is on page number we derived last time, which is on page number 156, equation 7.6. We derived rho GV. We will use this equation to solve the example 7.5. An empty meteorological balloon weighs 10, 20, 80 Newton. It is filled with 10 cubic meters of hydrogen. How much maximum contents of balloons can lift beside it, its own weight? The density of hydrogen is 0.009 kilogram per cubic meter, and the density of air is 1.3 kilogram per cubic meter. Weight of the balloon, as it's given now. Now I'm going to write given data, and given data is weight of the balloon is given to me, which is 18 Newton. Volume of hydrogen is also given to me, which is 10 cubic meter. You know the unit of volume is cubic meter. So volume is also given to me, which is 10 cubic meter. Density of uh, density of hydrogen is given to me 0.09, and the unit of density is kilogram per cubic meter. Since there are two densities, so density of hydrogen, so I denote density of hydrogen is rho 1, which is 0.09 kilogram per cubic meter. And density of air is also given to me, which is 1.3 kilogram per cubic meter. So density of air I denote rho 2, which is 1.3 kilogram per cubic meter. So in this numerical, we are going to solve. He asked to find out how much maximum content the balloon can lift beside its own weight. So weight of the hydrogen W1 and weight of the hydrogen W1 we need to find out, and weight of the contents W2. I denoted weight of the hydrogen with W1 and weight of the content is W2. So first of all, we will use the upstress force because upstress force we will calculate, and the formula for upstress force by using Archimedes principle we derived last in our my last lecture. F is equal to rho 2 Vg. This is I will use this formula rho 2 Vg. Where rho 2 is 1.3, you can see density of air is 1.3. I will just put the 1.3, and V is volume is 10. I will substitute 10, and then I will G value of G is 10 again. You know the acceleration due to gravity is 10. So if I multiply this 1.3 multiplied by 10 multiplied by 10, I will get 130 Newton, which I calculated the upstress force. Now I use the weight of the hydrogen because weight of the hydrogen is unknown. So weight of the how will we use the weight of the hydrogen by using the formula rho 1 Vg. Rho 1 is also given to me, which is 0.09, and V is 10. You know we have already found V is 10 meters to cubic meter, and value of acceleration due to gravity is 10. So 10 multiplied by 10 multiplied by 0.909, you get 9 Newton, right? I repeat, uh, empty meteorological balloon weighs 20 Newton. So force is weight of the balloon is W, is not with W, and which is given to 80 Newton. Volume of hydrogen is 10 cubic meter. This is also given to me. This is also given to me. Weight, so volume of the hydrogen is V, which is 10 cubic meter, and density of hydrogen. This is the density of hydrogen. It is written the density of hydrogen is 0.09 kilogram per cubic meter. The density is I denote density of hydrogen with rho 1, which is 0.09 kilogram per cubic meter. The weight of the hydrogen we need to find out, and density of air is also given. It's written here, and the density of air is 1.3 per kilogram per cubic meter. It's given. So first of all, I will calculate the weight of the content we need to find out. W1 and W2 we need to find out. So wait, first of all, we calculate the upstress force, and in last lecture, Archimedes principle, we calculated the upstress force, which is rho Vg. Okay, so F is equal to weight of air displaced. The formula for upstress force is rho 2 Vg. Rho 2 is 1.3 multiplied by 10, V is 10, and value of G is acceleration due to gravity is 10. If you multiply this 1.3 multiplied by 100, you get 130 Newton. Weight of the hydrogen, we need to calculate W1 since these two things are unknown. So I will use rho 1 OVG. This is the formula we calculated last lecture. we derived this one in our last lecture. Rho 1 is 0.09 and V is again 10 and G is acceleration due to gravity is again 10. So if you multiply 0.09 multiply by 100, you will get 9 Newton. So this is the formula. The upsurge force equals to the weight of the objects. So there are the three weights, W plus W1 plus W2 is equal to upsurge force. And you know the upsurge force we calculated. Upsurge force we calculated F is equal to 130 Newton. And W1 is I calculated 9 Newton. And W1 I calculated this 9 Newton and F is 130 Newton. I will use this formula. So W is equal W plus W1 plus W2 is equal to F. So W is given to me 80 Newton in my last when I wrote the given data, and W is 80 Newton and F is 130 and W1 is 9 Newton. So I just put the values 80 plus 9 Newton plus W2 is equal to 130. If you 80 plus 9 is 89. If you take this on the other side, it will be plus 89. If it is on the other side, it will be minus 89 Newton. So 130 minus 89 Newton, you will get 41 Newton. The maximum weight of 41 Newton can be lifted by the balloon in addition to its own weight. So we calculated W2 weight. This was unknown. Now I'm moving towards example 7.6, which is on page number 159. Please open page number 159 because I'm going to solve example 7.6. I read the example statement first. A barrage is 40 meters long and 8 meters broad, whose sides are vertical floats partially loaded in water. If 12,000, 1,25,000 Newton of cargo is added, how many meters will it sink? How many meters will it sink? Okay. A barrage 40 meters long and 8 meters broad, whose sides are vertical floors partially loaded in water. If 1,25,000 Newton of cargo is added, how many meters will it sink? So first of all, I read the given data, and the given data is area because two sides are given, 40 meter and 8 meter. It's mean when there are the two sides given, it's mean area is given. How we will calculate the area? 40 multiplied by 8. This is 40 meter and 40 meter, and this is 8 meter. So we can multiply this. We will get the area, and the area is 40 multiplied by 8 is 320 meters square. Additional load of the carries W. Load is noted with W, and it is also given to me 1,25,000 Newton. So this is the force given to me. Next, increased upsurge force of water must be equal to the additional load, because in order if the object wants to sink, the upsurge force is greater than the object weight of the object. So I will use the formula F is equal to rho Vg. We derived this formula in my last lecture. F is equal to rho Vg. Since F is equal to W, so I can place F with W. I can replace F with W. So W is equal to rho Vg. And you know the density of water is, which I told you in my last lecture, the density of water is 1,000. It is understood as you memorize the value of G. The value of G is 10 meter per second scale as you memorize the value of acceleration due to gravity. Similarly, you need to memorize the value of density of water. And density of water is 1,000 kilogram per cubic meter. Okay. And the weight is also given 1,25,000. So you need to find out V. So these two things are multiplied. Multiply this 1,000, multiply by 10. You will get 10,000, and when 25,000, 1,25,000 divided by 10,000, you will get 12.5 meter cube. This is the volume. And in my last lecture, if you want to find out the volume, you need to multiply area with height. In my last lecture, when we drive Archimedes principle, so I told you when you, if you want to find out the volume, so in volume, area multiplied by height. So since I want to find out the depth, so because he is asking us how many meters will it sink, it means it is demanding us the depth. That's why we find the height. So we use this formula. Formula is V is equal to A times H. So in order to find the H, separate out. So V divided by A. Volume I just calculated is 12.5, and uh, area I calculated is 320 meters. So substitute these values. 12.5 cubic meter divided by 320, the depth you can find is 0.04 meter, which if you convert this meter into centimeter, so that will be 4 centimeter. Thus, the barrage will sink 4 centimeter in water on adding 12 5,000 Newton cargo. If we add the weight, 1 lakh 25,000 Newton of weight, the barrage will sink 4 centimeter in water. Okay, so this is the example we did. 7 point. Then example we discussed. Example 7.6. So now I'm moving towards the next topic, which is 7.8, elasticity. 7.8 is elasticity. So figure 7.22, a spring is stretched by a force. A here spring, if we apply the force over here, the spring will stretch. The spring will expand. In B, this is the B, a rod is twisted by the torque produced by the couple. So this is a rod. So if you apply the force, the rod will twist, the rod will move by the torque produced by the couple. A strip is bent by a force. This is a strip. It is, if you apply the force here, it will bend, it will go down. So in first figure A, in figure 7.22A, spring is compressed. Here, rod is uh, twisted by the application of the couples, and in the third 7.22C, a strip is bent by the force. Here we apply the force, the strip will be bent downward direction. So this is just because of the elasticity. The definition of the elasticity is the property of the body to restore its original size and shape as a deforming force ceases to act is called elasticity. This is the definition of the property elasticity. The definition is the property of a body to restore its original size and shape as a deforming force ceases to act is called elasticity. For example, if you apply the force on the spring, if you apply the force over here, and if you release the force, if you move your hand, so what will happen? The string will go back to its original position. I repeat, if you apply the force over here and the spring moves on the right hand side till here where my cursor is pointing out. If I release it, if I release the spring, or if I cease to apply my force, what will happen? The spring will go back to its original position. It was its original position. This was its original position. If I apply the force, it will move on the right hand side, and if I release it, it will, if it is go back to its original position. So this is called elasticity. Uh, but what will happen if you keep on moving? A stage will come. The spring will not go back to its previous position, but it has the permanent deformation will be placed in it. That permanent deformation will be occurring. It will not go back to its position. So, but in elasticity, we are talking about within the elastic limit. So if we are moving over here, so if we release the force, it will go back to its position. Where the body go back to its original position, that phenomena is called the elasticity. Okay. So the property of a body to restore its original size and shape as the deforming force ceases to act is called elasticity. The next one is stress. The deforming force acting on unit area of the surface of the body is called stress. So there, after studying the elasticity, we have two more concepts. One is stress and other one is strain. Stress, how we define the stress? The deforming force acting on a unit area. Force per unit area is called stress. And you know the pressure is equal to, pressure is also defined force per unit area. It's mean pressure is a stress. So stress is equal to force per unit area. The formula for stress is force per unit area. And the unit of stress is force unit is Newton and area unit is meter square. The unit of stress will be Newton per meter square. You can see the SI unit of the stress is known as per Newton per square meter and it is denoted as Nm minus 2. Nm minus 2. The SI unit of stress is Newton per square meter and it is denoted with Nm minus 2. Now we discuss another concept which is called strain. When stress acts on a body, it may change its length. When stress acts on a body, it may change its length, volume, or shape. A comparison of such a change caused by the stress within the original length, volume or shape is called the strain. The strain is defined as tensile strain. We say it's tensile strain because there is a change in the length. Therefore, it is called tensile strain. And the tensile strain defined as a change in length divided by the original length. So strain has no unit because the unit of length is meter and the unit of original length is also meter. Both are the lengths. So they will be unit. The meter unit will be cancelled with the original length meter unit. So it has no unit. Strain has no unit as it is a simple ratio between two similar quantities. So it is also a strength. This is the strength. So strain has no unit because it is the ratio between two similar quantities. So students, so what we discussed? We discussed about the elasticity. We discussed about the elasticity, the property of a body to restore its original size and shape, and as a deforming force ceases to act is called elasticity. So I told you the example of elasticity. Spring is the example of elasticity within the elastic limit. What does I mean elastic limit? If you apply the force over here, it will go back to its original position. But at if we keep on applying the force, the time will come when we release the body, it will not come back to its original position or original size. So that is not elasticity. This is out of its elastic limit. So we need to remain in the elastic limit as long as when we release the force, it will come back to its original position. The property of a body to restore its original size and shape as a deforming force ceases to act is called elasticity. So after studying the elasticity, we have other two concepts, what is called stress and other one is called strain. What is stress? The deforming force acting on a unit area. Stress is like a pressure. Pressure is defined as force per unit area. So stress is also force per unit area and its unit will be its SI unit is or unit of stress is known as per square meter. Newton per square meter and it is noted with Nm minus 2. There is another concept which is called strain. When stress acts on a body, it may change its length, volume, or shape. Whenever we apply the pressure or the force, so the three things will occur. Whether its length will be changed, the object length will be changed, its volume will be changed, or its shape will be changed. I take the example of if you press the press the ball rubber ball, what will happen? It will change its shape because we have pressed it. It has changed its shape. So if we release it, it will come back to its original position. So whenever the stress is applied on the body, it volume change, its length change, or its shape change. But tensile strain is change in length divided by original length. So strain has no unit as it is a simple ratio between two similar quantities. The change in length unit is meter and original length unit is also meter. The units will be cancelled out. So tensile strain has no unit. So this is the end of the topic of today's lecture. We discussed about uh, we discussed about what we discussed. We discussed about principle of flotation, and then we did example 7.5. And ships and submarines, we discussed example of principle of flotation. These are the example of same principle of flotation, why the submarine floats and why the submarine sink, and why the big ship float on the surface of water. This is just because they were designed on the principle of flotation. Then we discussed about the example 7.6, and then we discuss elasticity and stress and strain. Stress and strain we discussed. If you students have any questions, this is the end of the today's topic. If you have any question regarding today's lecture, please feel free to ask questions. Thank you. And your homework is, I'm going to tell you. So homework is memorize the topic covered in today's lecture by heart and write them down once on a rough register and solve example on the rough register. I will not check the rough register, I will check only the neat register. Memorize the topic covered in today's lecture. We discussed about principle of flotations. Uh, Try to memorize the definition of the principle of flotation. Then try to memorize the examples. I discussed ship example and submarines. These are the example of the principle of flotation. Then try to solve the examples on the rough registers, the numericals we discussed today. Try to solve them. If you have any questions regarding today's lecture, please feel free to ask us. Thank you. Usman, do you have any questions regarding today's lecture? Please feel free to ask. Behave, Usman, unmute your mic and ask us.